You Scooby Dog. He's helping me out today again. I'm going to get rid of this shovelhead exhaust port here. I welded this up. So I'm going to machine it. And I just noticed that the intake port was all broken out. If I saw that, I would have fixed it before. So it looks like this thing might have been an accident. It's cracked right through the port down low, not right at the lip here. I was looking, I kept seeing a little mark over here. I thought, what the hell, is that a crack in there or something? See the mark come right there with my thumbnail? And it comes right along the base down there, right on the edge. Cracks right along that edge. So that thing's cracked at an angle, about an angle like this, going right through it. So this whole piece here is about ready to fall off. So that needs to be fixed. So I'll have to go weld this all up and remachine this lip again. So I could do two things on this head. Alright, so for now we'll go ahead and do the exhaust port. So I already filed off the lip right here a little bit. And I hit the tool right here. Centering tool. See, it's not quite flat. That's because this is all uneven all through here. So that's where I saw the crack in there. I was working on it. Alright, so put the camera over here. Scooby's going to stay down there and help tonight. He likes doing that. So you got to file the gasket surface a little bit, just to make sure it's flat. So you take a fine dull file. Now this one here I don't mark it for which way is up, so I'll grab another fine file. This one's marked for which way it's bowed. Run it across. Knock off any high spots. Seems to be good. He didn't really cut all that much. Just hits on a few high spots here and there. So you can tell that this is not very flat right through here. You run your finger across, you can feel it too. It's high right where that mark is, and it's low right there. You can feel it humping up on it. Yeah, so this whole area's got that same wear mark to it. From here to here has that feel to it. So that means we'll probably have to do a little trim kind of on the top of the head too. Head gasket surface. Everything needs to be worked on. Yep. Alright, let's put this over here. This is not working very good. There we go. See what I'm doing? See what I'm doing and be out of my way. That's always important. Okay, so this is at the angle it needs to be at. There's my cheat sheet. Turn the light off. Yep, you might see better maybe, I don't know. So there's the cheat sheet. So if you don't want to spend hours and hours and hours and hours and more hours figuring it all out, that's the cheat sheet. So we're going to do 53.5 degrees for the rear head. That's what this is at. And that was off an S&S head. The Harley head was 54.2 I used to use. So I changed what S&S is, 53.5. Okay, and intake is at 90 degrees. So we can figure that out pretty quickly. And we'll show you what that is in a minute. Now if we're lucky, a couple of bolt holes will line up over here. Looks like this one right here. That's not going to work. Need my two strap clamps here. Try this again. Okay. Got one right there and one bolt hole right there. Okay, put light pressure on it. Yep, camera's in the way already. Okay, so the intake port's 90 degrees. That makes the rotation for here correct where it needs to be. Kind of important. Hammer. Very important tool. Gotta have one. Beating on it. We like to beat on things around here. Alright. That looks close. Light pressure. Come off this face right here. And when the digital level's at 90 degrees, we're there. Now on the level you have to make sure you're at 90 degrees this way, not this way or this way, because it changes the angle when you go like this or like this. You need to be vertical to measure your 90. So that's important also. So right now we're at 90. That's not bad for guessing, huh? Double check. 90. Put a little more torque on it. Now I'll try with my tool coming off the other surface, because the O-ring lips get destroyed on these heads. But in this case the other surface is bad too. Now we're at 89.7 degrees. Rotate it. Let's see, make sure I'm vertical. 89.8. We're at 90 if we rotate up. So, if you go off this, we're 90. So I'm going to go just a little bit more. Go 1/10 of a degree more. And now it's 89.8. It's 2/10. I'm going to put this up there and see what this is. 89.9, 90, 89.9. Kind of all over the place. And we're 89.90, depending on where you put it. Okay, so we'll go with that position there. Actually, that's good and tight. Okay, so that gets our rotation of the head this way, and then the angle plate puts it on the angle that way. So it gives you two planes to square off, and that will give you a true angle now. That should get us within about 10 or 15 thou being what it should be. Of course, you never know what it's supposed to be because every head you measure is different. So you just kind of go with it. Alright, so now I got to face this thing off flat, and I'm going to have to get a depth from someplace. I don't remember where I was measuring that from. Let me read my cheat sheet. Maybe I'll have some kind of a number to go by on something. Probably not. Probably just wing it. Let's see, 1 and 0.050 from edge, angle of plate, top. So from this surface here, that is 1050. That's where the S&S head was. So we'll go with that number. So we have to get our, need to zero this out. So we make this 0, that gets rid of the thickness of this. We lay that like that. Just screw my damn calipers. Okay, then you come over here and measure this. So right now we're 1.152, and that was a very uneven number. So hopefully when we make it flat we're high. I think we will be. Alright, so we can go ahead and get that cut off. Here's our face mill here. Got bits on the bottom. Makes chips and lots of noise. Camera's in the way. What a shocker. Uh-oh, I'm in the camera. How'd that happen? Unlike video TV, we don't have me in the picture. We only care about the work, not the darn person doing the work. At least I do. Alright. That all the way down. Appears to be off a little bit. I got a little bit of a gap I got to take up here with the hand crank. So I get to go down here and do some manual labor down here. It brings the head up like that till we hit. There we hit. Alright, we'll do a 50 pass. Kind of get an idea where we're at. I deaden the vibration by doing that. I could put a clamp on it, but I'm just using my hand as a clamp. Okay. Now we almost got something to measure from. So now we do this measurement again. Roughly we're 158. It's almost the same thing. So we want a 1050, I think. Yep. So we got 100 thou to go. Our dial's set on 50 down here. So I'll give it 100. So we'll go 50 at a time. There's 50. Do this again. Remember, keep your hand away from the cutting tools at all times. I would never get close to the cutting tool. Scooby don't care. Thou more. Check something here real quick. Yep, make sure that bolt was all the way down. It is. Otherwise I have an error in my measurement. Okay. Now we try this again. This time I need to get on the other side where I can actually measure it correctly. So I got 62, whoop, 1062. So I got 12 more thou to take off. Okay, so we'll go right to 60. We were at 48, so that should make us right on the money. Faster speed, a little better finish. In case you don't know what this is, it's a shovelhead. Appears to be a 74-inch shovelhead. I think it was a 77 head, but I'm not sure. Alright, here's our little bit smoother finish now. So there's what it looks like right now. See all the aluminum that was in there, different alloys and stuff. So anyway, that's what it looks like right now. So now you gotta move on to the next stage and bore a hole. We get to determine where the hole's at though. That's going to be fun. The only way we can figure it out, we have to put the bar in there and just cut until we get what we want. Alright. That one out. One boring head. I poked it right in the hole. And eyeball the center. We just have to rough it out until we get to find the center of the port. It'll take a few attempts probably, but we can handle that. Okay, bowling bar. These are standard insert boring bar here, 3/4. Appear to be not quite centered. Drop it down a little bit. Zero. Okay. Kind of eyeball our center point. Just center up the hole it's got to work with. High speed there. And you go ahead and move it out a little bit. Yeah, that'll cut a little bit, not much. that deep. Set your depth stop right there. What number are we on? We're on 40. Maybe we'll go to 50. Okay. We're cutting at 1500 RPM right now. We'll probably drop that back just a little bit. So, there's our speed way up there. So, crank the handle down in the wrong direction. Well, we're in no man's land, that's where I like to be. That's 1200. I like to be in no man's land. Engage that. We're feeding up instead of down. Now we're feeding correctly. We're going to go down until we hit the depth stop here and then we'll shut off. Hitting somewhere in there. I'm not hitting anything right now, so we got a little bit more to go and we'll shut off here in a minute. Pop the handle. And there's our cut right there. Now we have to figure out where the port is. We just have to get it centered up in the port. Until we get closer, we have no idea where we're at. Okay, so we're going to take a 1 cut, 2, and there's 3. Go right to 0. So that's 150 pass. A nice light cut. A little pressure on that. We're on. Engage. The handle's going down. A little bit of a cut. We only see something. Appears to be vibrating slightly. Considering the uneven cut, that was expected. Deeper. A little bit more. And we're done. We're done cutting now. Okay, so now we got a little bit of something to go by. We're still nothing cutting on this side yet. We are cutting on this side. We're cutting right here. So you feel how close it is on that side, you go over here and feel how heavy it is on that side. It's not even close. Got a pretty good gap there. Decent amount of gap on that, but we're not even hitting here yet. Okay, so we turn on our digital readout. 0 it. Go ahead and crank this handle here, which will move us in about 10. Yeah, there's 12. Close enough. That'll make it a little bit bigger this way. Yeah, it probably is. Actually, I think I'll leave that where it was. Yeah, close enough. See, I'm looking at how thick it is here and how thick it is here. It's about equal. Close. Something to go by. Now, see this side here, see how thin it is here, and look how thick it is over here. So we definitely got to move it that way. So we're going to move it this way here a little bit. Oh, there's 50 thou. That's a good little movement. That's a pretty heavy adjustment. It needed it too. Okay. Go ahead and give this a... It's going to take 50 to make any difference at all. And I'm going to cut 60 is all I'm going to cut. We'll get this thing dialed a little bit close before I keep making heavy ass cuts. I'm cutting on this all on this side here now. Still not hitting over here at all. So we are going to move it that way a little bit now too. Boom, it shuts off. Just after it quits cutting, it shuts off. Okay, so now we got a close there, not even close this way. Way off that way. Okay, so I'm going to go another 20 something thou this way. Let's go 25 more at 75. We'll zero you out. Okay, how close are we to cutting this side now? Okay, it appears that we're not even close to cutting on this side yet. So we just 25. There's 30. Pretty good gap over there. I'll give it 35. Okay, we'll zero that out. Gives half a turn, a little extra. It should get us to where something starts to cut over here in this corner. So let's see how close we are to cutting over there. We're not even cutting on that corner. Okay, so we'll go all the way to 50. Alright, another big cut. See what happens. Big adjustments. Alright. Not cutting around, but we're getting closer. That off. Okay. Alright, let's get an idea about what size we are. 6-inch scale. Where's our port OID at? 1 5/8 is the ID at the bottom. We're getting close to that already. Yeah, we're at 1/4 something. So we're not 1/4. We haven't got close to where our center of the port is yet. That's not a good sign. We're still way off this way. It's still real thick at the bottom of the hole. Way off. This one's close. This is basically done right here, I think. And over here we just cut. We just caught it, but we are cutting this one almost done. So whatever we're going to move it, we need to move it equally to compensate. So I'm going to go another 25 both ways. Yeah, we'll go 30, 25. I'll do 25 that way. We'll do 25 this way. That's going to take a 50 pass to even do anything. So there's a 50. Probably take more than that, but 60. Once again, we're going to be cutting real heavy right here. And we can see that happening. Okay, we're coming up about 460, 470 right now. Okay, that is real close there. Still way heavy on this side. Those are starting to feel equal. Okay, I'm going to zero this out again. We'll give this 25 on the bottom. Yeah. 25. Give it a 50. It's half a turn. Okay, we might actually start cutting over here on this side here again. All right. So we don't really have anything to go by, so we just kind of make do. There might have been some dimension off this bolt here maybe, but I'm not sure. I don't think I ever did that nose yet. We're going to clean out the crap in the bottom of the hole there. When the chips dig into the cutter, it causes issues. Okay, so the only part it didn't clean is that little line right up through here, about a 1/4 inch worth. So at least now we're back a full round hole. Give you a better idea where we're at. Okay, so we gotta clean those chips out. So we got chip cleaner over here. Alright, so now you see how big the lip is right there. Come over here and see how the lip is right there. See how little of a lip we got here. We got a big lip on the back side over here. Got a big lip down there. So we need to take all that material out on that side again. Okay, so we're about 520. So I'm going to do another 25 more right here. Oop, not 50. 26, close enough. So we're going to be cutting this direction here again, this way. Now side to side wise, I think I'm pretty close on that. I'm going to leave that for now. I think we're getting pretty close on that dimension. So get us a 50. Do it again. Once again, all the cuts right here. I'm not cutting it all on the top surface. Okay, finally got it cut down a little ways down. Still that heavy lip, not much lip on this side at all. So I don't want to cut any more material off this side at all. Probably already cut too much. That feels okay. That feels pretty centered that way. You look at the thickness of this and the thickness of this, we're close. That's a good sign. Oop. Alright, so I need to cut that way. So much more we got to work with here. Looks like we're about 550. Flip it around this way. Yeah, we're about 565 or so. So I'm going to give it 20 more. Actually, I'm going to give it 25 more. There's 25 more. I'm only going to give it 40 over here though. We're at 10, so we'll go to 50. 50 on the dial. Oh, 50, not 52. Damn it. Go back until I get what I want. Where's my number at? That is 50. Yeah, 49 is close enough. No, we're not even going to cut right here. We should have some gap. Not sure how much. Got about 10 or so at least. Gonna finish the hole and we'll just kiss it probably. Just gonna take another good cut off that side. That's good. Pretty hard down there, wherever that cut. Weird sound to it. Alright, starting to get close on that side. We're still closer on that side though. Good. Good. Alright. Gotta clean the chips out again. plug up the back of the hole, the vacuum increases out of the hole, so it sucks the chips out. Okay, I gotta measure that. I'm gonna actually measure the hole with a caliper now. Now top this way here we haven't hit yet, so this is not a true number. We're at 621 right now that way. Now if I measure this direction over here, it will be accurate because it was cutting all the way around on that side. So about 613, 614. So I got about 10 or 12 thou to go. 10 or 12 thou should clean the rest of the hole up. If I want to make any kind of a move right now, side to side, I need to do it now. I think I want to move it this way about 4 or 5 thou. We'll go with about 4. We don't have a lot of material to work with, so 3, 9. I'm going to leave the other number alone. I'm going to move it 12, which will put me about 61. And that. Alright, let's see what we get. Really welcome to clean the whole hole up. Let's see. Looks like it's cleaning the whole hole. That's a little shiny all the way around now. Light cuts will let the cutter get a better finish. A little bit lower. I went lower because it wasn't clean on this side all the way down. Now it is. Yes, the port could go this direction. My finger is over here a little bit more. But we're out of material, so we're not going to. Yeah, we're probably off by about 10 to 15 thou. Yeah, probably about 15. Oh well. I don't think the exhaust pipe will ever know the difference. So right there looks like just under 25. I'm guessing we're a couple thou light. Get this out of the way. Nope, we're actually good. 26. I was off by 3 thou. Guess my eyes are getting bad. Maybe I'm tired. It's late. So what's nice about a 6-inch scale, you can measure each one of these little lines right here is 10 thousandths. So when you measure these things, each one of those little ones is 10. You split it in half, that's 5. You split it in a third, it's 3. So you should be able to guess within 3 with a 6-inch scale. At least your eyes are working anyway. Okay, so we're on our center point. I already zeroed that, so we're zeroed. So now this part here is done. Now the next number is the step we got to do. The shovelhead's got steps in the ports. So we just bored this part here. Now we got to bore the actual pipe diameter here. And see this head here, most of these early ones don't have any material in here for that step, the lip. So the exhaust pipe overhangs directly in the port and causes a flow problem. Or if they're overported. Here's a spigot. Catching on something there. Alright, here's your spigot. So this goes into the hole right there. That's how you figure out where that hole goes to. So now we got to bore it for the pipe to actually go into the port. What are you doing, Scooby? Scooby's not happy. They're firing fireworks or gunshots earlier. He didn't like those. What are you doing down there, Scooby? You camera shy? He's nervous. Okay, so I got to go down a certain depth now also. So I need to go down, I think it's 600. Let's see, Y is 850. all kinds of dimensions, but not the ones I'm looking for. Where's the numbers at? There it is, 600 deep. See, these notes are so damn old, you can't read them anymore. So I got 755 by 600 deep. So that means this will be 755 on the OD, and this must be 600 deep. Where's my scale back? Plus a gasket. See, without the gasket, we're about 550. So we'll make it 600. When you have a gasket, you have a gap in there. Technically, I don't have to, but factory goes in 600, so that's what I do. You can probably live with 450-ish. Would probably work fine. All right, so now we're going to have to set our depth stop for up here for how deep we want to go. So first thing I'm going to do is go down until you're about flush. So this is 15 tile thick, roughly. Let's see, we're zeroed right here. Okay, that's a good thing to be. You move this up until you get about 600 thou. This is a 1/2 inch wide, so we're a little over 1/2 inch right now. So that's a little bit more than 600. And that's should be close to 600 right there, a little bit under. So we should be a little on the light side, probably about 50 thou light, which one more notch down, probably getting pretty damn close. Okay, but we don't know where we're at, so we got to find out. So what we're going to do is we're going to go ahead and turn this a little bit to get a little depth to cut. So we gave it a 50 pass here. Oh, I did this wrong. I should have had that. This is where it pops. Now we are going to be light, so now we're 1/2. You have to go by where it actually stops. That's probably pretty close. Okay, now we're going to try it. Okay, take your scale, lay it in there, and we're about 40 thou off right now, it looks like, maybe 50. I'm looking at it at an angle, so it's hard to tell. I'm on the lip right now, so yeah, we're at least 450, 550 I mean, so yeah, we're probably about 40 thou light. So if we crank this up 40, should get me pretty close. So there's 35. Give ourselves a little extra. Okay, now we just do that again. Feed right into it. Alright, try it again. Right on that 600 line. See how that line is right there? Appears to be right on the line there. Pretty close. Close enough for now anyway. A few thou one way or the other ain't gonna make no damn difference. Okay, we went 50 thou bigger than we had, and we were whenever we're 625, 675. So one more of these should put me at 725, which should leave me about 30 more to go. Without even measuring it, you know about where you're at. A little bit of porosity there. You see that? Oh, we got black way in the back corner over there. I'm getting close to the original material. A couple spots there. Somebody didn't weld it very well. See that little line of crap right through there? That's called porosity. It's a bad weld. Inferior welder did this job. How about this other side? Everything else looks good. Oh, we got a pit over here too. Look at that. All the bad parts are coming in now. It's hard to get good help. Okay. Scooby's passed out over there. Okay, we're gonna, we're about 735 I think we're at. Yeah, we're at 725. There we go. Yep, 725. Not bad for rough idea where you're at. Okay, we're at 57. We had what, 25 to go. 5, 15, 20-ish. Should leave me about 5 for finish. Let's see if all the porosity goes away. And nope, some more stuff showed up. And still got a little pixie over there. This side looks good. Yeah, crappy ass welders. It's hard to get good help. Yeah, there's a couple pits over there. Yep. Definitely not a very good job. And we got 4 or 5 left. Looks like I got about 5. Oh, we're going to 55. Excuse me. I was thinking of 50. No, I got 10 more to go now. I was off. Okay, so we're at 76 and a half. 86 and a half. Should put us within half a thou of what we want. Still going through that pit area. We uncover new ones as we cut the old ones out. And looks like we uncovered some more over on this side. Yeah, there's a hole right there. Damn crappy ass welder. I'm gonna fire that guy. Wonder who did that. Look at that, 74 and a half, maybe 3/4. See, told you it could be within a half. Now if I flex it, I can get up to 6, but I have to, or up to 5, I mean. Right now we're hitting on the side of this thing here, which is not helping the number any. There, that was worth about a half a thou. I was hitting on the side of the boring bar. Alright, so there you go. So you can get pretty damn close if you want to. Now we don't know if that tool's accurate, but we're going by whatever the tool is. The tool says we're good, we're good. Alright, so now we have a funnel effect going on here by having that lip on there. Now I'll come in here later and I'll blend this into the port with a taper so we won't have that lip on the bottom. But the exhaust pipe tip is going to be hidden, or it's basically flush. So this here, you won't have much of a gap ledge for the air to hit against. It'll be basically be flush going into it. So that's what you want. Alright, so right now we need to do 2 things. We need to get the hole over here, and we need to chamfer this outer edge. So I'm going to put a chamfer on the edge right now. Use a chamfering tool for that. Same one we used on the painthead job. You can use these tools for multiple applications, see. Alright, here's our chamfering tool. Same one we used on the panheads. And unlike a panhead, I can't cut the outside because it's teardrop shaped. So we'll have to do that all by hand. Now I can rough it in with an end mill if I got a lot of material to remove. Just by freehanding it. Look at our angle here. It appears to be pretty close. That's good. Okay, now you can see how we're cutting way too big. So I have to crank this thing out some more. Get rid of our depth stop. Okay, that should be a good starting point. Yeah, got some Tribodon on my hand. It's stained for life now. Okay, we want to go, I think, 50 thou deep on the chamfer, as I recall. Let's see. Chamfer 90 thou. Ooh, that's a big one. 90 thou. So that means to go half of that. 45 thou down. Pretty big cut. Alright, let's see what we got here. I'll turn this down quite a bit. There's 840. Okay, so now I go down over here. Okay, we just started cutting. Put my dial at 60 over here and down here. I don't like that down this, I'll go to 50. So theoretically I can go about 45 thou to get a 90 thou chamfer. So we'll do that pretty quick. 30. And get the hell out of there. Now if I keep pressure on it, doesn't chatter. When I started to slow it down, you heard it chatter. I sped it back up on the feed rate and the chatter went away. You have to get in and get out. Okay, so now we got a pretty good chamfer. I'll go ahead and measure it. Looks like we're a little bit light. And I'm only about 65-ish or so. Looks pretty good though to me. How much is it supposed to be? 1850 on the OD. 1850. Yeah, we're about 825. We're definitely light on the chamfer. Okay, so we can go ahead and give it an extra 10 thou. After 45, I gotta go to 55 now. Chatter in that. Looks like we're still a little bit light. Dark over here. Always measuring where it's dark. Oh, it's actually a lot closer when you get light on the subject. Yeah, about 840-ish. I think we're close enough. Close enough to government work, right? There's a chamfer low depth. Depth looks good. Looks like a 90 on the depth. Alright, so that's pretty much what we want. I'll show you what I was doing here. So get my scale. So we got two dimensions. We got the length of the cut right here. So that's 100 wide. And you see how you're just below the 100. If you flip the scale around, you got your 10 thousandths marks here. Now the end of the scale is kind of gone, so it gives you kind of a false starting point. So you see we're about 85 or 90. I don't know if this thing's going to focus in on that or not. Probably not. And then this direction here should be about 850-ish. I think the light's hurting us. Can't even see it. I can't even see it with the light on. Okay, there's 2 inches there. See the mark over there? I don't know if you can see it or not. Oh, that helps. Yeah, get the light off. I think the light's killing this video. How about that now? Get the light. So right about 840, I think. Alright, so now we got the chamfer all done. Now we got to do is put this up in there, and we got to see where our holes are going to be. So we get this bit out, and let's see what happens. I don't think I've ever got a direct dimension on what to go to either. Strictly an eyeball. Theoretically, I could have had some kind of dimension that could have came from if I wanted to. We got a bolt hole that's kind of maybe sort of usable. We know where we're at in the center, so we know about how far off we should be on our XY to put in the center. Pretty close. So if I did some better dimension, I would probably know these numbers. They might even be written down. I just haven't found. Didn't look at them. That happens too. And I do have some dimensions. See. Yeah, I did do that at one time. On the front head I haven't done, but I've done the rear head. And we're working on the rear head. So X is negative 750 and Y is negative 900. So we go 7. Which one was which? X is 750. And this one's 900, negative 900. 7, 8, 97, 8, 9. 2 more tens. Come on, come on, come on. 9. 900 right there. It doesn't even look close. Not even in the ballpark. It doesn't surprise me. Alright, let's get this out of here. Can't really go by numbers on a piece of paper. Don't know who did that, even though I know it was me. I might have been wrong that day. Okay, where's my spigot? Okay, I got a carbide tipped scribe. That's one of my tools. The other one is I made back in the, I don't know, 80s, early 80s. This is a drill bit that I sharpened. I got a piece of hard rubber they used to use in the mold machine, in the stamping area. Real hard rubber. So anyway, there's your point. I like this one better. It gets into tighter areas. We can use them both. Okay, you basically lay that down. Guess we're about where the center point of the port is at. Have to guess where the original port was at. Somewhere in that area there, I think it's pretty close. These dimensions here aren't even close to that dimension. Center line is 300th out from the edge of surface. Yeah, no squat. But those center line dimensions aren't even close. I don't know where those came from. Those are from some other dimension from some other place. Looks like we had an XY dimension up here we could have used. Coming from somewhere else. I'd have to figure out what those numbers were. I don't know what they were from. That's why the other numbers are off. Oh well. See, if you don't do these at least once every year, you kind of forget, right? Luckily, it doesn't really matter. As long as we're in the ballpark. Close enough. Alright, let me get over here where I can see the port at. The original port was way over here. So closer on that edge. Not a bad position to see, but alright, I think we're about in this area here. I've got so much material welded on that port I can't tell where I need to cut. Inside's really good though. See the alignment down in there? Pretty nice. Good for power. Okay, I'm trying to see where the original port's at. Where'd my scribe go? Yeah, we'll use my scale. See, this is all weld buildup out here. See, the actual port's way the hell down here. The original port, it's way under there. So that's the original part of the head, way down here. So if you go straight up, you should be on the edge of that. If you come over here on this side here, it's about there. Straight up, that's about where that's going to be. So I think I'm pretty close to straight up. So I'm going to cut some of this material away so I can kind of see where the hell I'm at. Because right now I haven't got a clue where I'm at. Somebody put a lot of extra material on this head. That damn welder again. Sloppy ass welding job. Must have got paid by the pound of material he put on. Put 10 pounds of aluminum on, you get paid 10 times more, right? Alright, so I'm going to cut that out of there. So I have to get an end mill. You stick an end mill in your drill chuck, but it's not very safe when you do that crap. So you should refrain from doing that. Alright, how about this one? Yeah, that should get the tight spots pretty good. Alright, there's no ball on the end of this, it's just straight cut. Sharp edge, so I don't like doing that too much in these type jobs, but gotta start somewhere, right? Now we could do this with hand grinding. Be here a while though. Okay, first thing I do is figure out where the hell we're going to go to. Obviously I'm going to go higher than this. So we get close and we got to move the head up. Okay, that's probably close enough for me to get my reference to. Okay, now I'm going to start making some chips. We have kind of a mark to go by, but we don't know how accurate that mark is. So I'm going to just give it a little bit. Cutter's not happy. Cutter wants some cutting oil on it. First pass off. Where we can see a little better. Excuse me. Now get a little more cut. our first pass. Now look and see how much depth we got under here. It appears we could probably go all the way to that line I got. So we're going to cut a little deeper. Still not a good view over there, is it? We'll move the camera again. See if we get in trouble. Yep. The port disappeared. Alright, so we're going to get that a little bit more of a cut. Maybe up a little higher might help. Okay, we've still got a pretty good lip down here to the side of the head. So I'm going to cut some more material off. So I'm going to move this over a little bit. Not quite that much though. Getting close to the edge of our board so we don't go too far that way. Cutting my black line. Quicker than hand grinding. Camera. We get the camera. I'm going to move the camera back a little bit. I'm going to cut the back side over there. Yep. Thin a little bit. Just lost half the brush. Oops. Keep the rest of the way down. Freehand cutting. All the line. And you can see it. I don't cut that fin right there. Lift it up a little bit. Usually when I do these ports, I don't have this much work because I usually weld the inside of the and not the outside. But when the port's really bad, and this one half the port was missing, you have to weld all the way around. Okay, so now we got a little bit better idea where we're at. So you can see how I cut onto my black line right here. I was cutting around freehand. You can tell it's freehand by all the back and forth movement. There's a little porosity right there, look at that. Okay, so you can see the original ports way down here my thumbnail is. So it looks okay. Over here on this side, still hard to tell exactly where it is because you got all this material in here. It looks like I need to rotate the pipe a little bit more. This other direction to be more centered. And you get back in the back. The tripod's always in the way. Among everything else over here. I need access to see the port. I need to be able to see down here the original head. The original head's right here, see? See, that's the original curve right there. Right there. If that goes straight up, we'd be on the edge of that. If this went straight up, we'd be on the edge of there. That one straight up would be in front of that. So I'm thinking it's about right in that area right there. Alright, I think that's pretty close. We're going to call that being where I want it to be. I can go ahead and put the scribe mark on there where the bullet hole is. And then we can figure out where the bolt's going to actually sit. Okay, I'm going to use my scribe. I like it better than that fancy store-bought job. Let's see here. This cutter's in my way a little bit. I know how to use it. And we have a mark. I got some extra material that needs to come off. I even know where it is. Be right there. Knocked off some excess material in the way. Okay. I got a good idea where we're at now. Knock off the burrs on the floor here. Gives you a reference to go by. It also keeps you from cutting yourself. You can't hit the top of the floor because you know where you're cutting. Okay, now we got to put a hole right in the middle of that area. For that, we're going to use a little bit of center drill right here. All right. And we just kind of eyeball where it's going to sit. It looks pretty close. You just do a little spot face. You just have to measure. Once you have a little spot face, you know where you're at. Alright, there's our numbers up there. So instead of being negative 900, we're 960. Instead of being whatever the other number was, we're 650. It was 750. So I'm not sure where those numbers came from. Did I re-zero those? Actually, I re-zeroed that, I think. I re-zeroed it. Okay, here's our mark right here. See the little pit right there? So we have an oval shape. So you look at it from this angle, and you got the edge of the pour here, edge over there, and it's kind of more or less in the middle. It's maybe slightly closer to the right side than the left, so I can move that about 10 thou. Go ahead and zero this out right there. Now we're 300 thou from the edge to the center of the hole. And we were looking pretty close, but maybe a little off, about 90, 85, 90. So I need to go about 10 one way and 10 the other way. So we're going to go 10 on the X, 10 that way, and the other one we got to go about 15 or 18 or so to compensate for the other angle we just did. Okay, so now we come back and respot it. And we'll have a new dimension to go measure now. So we want 300, and we are pretty close to 3. Another 5 wouldn't hurt. In this direction here, we now look like we're a lot more center between my thumb and there, and from here to there. So I'm good with that. I don't think I have quite my 5 I want. So I'm going to zero that out. We're going to give that another 5 right there. And that's going to move me slightly close to that corner, so I got to back it up a couple. 2 back. Try it again. Okay, that's about the last time I can do that, because now I'm at my full chamfer size. So now we look at our 300 right on the money. It looks pretty good right on the edge of the hole. 300 thou. And we're pretty darn centered right to there. I'm happy with that. Alright, so we got our dimension in there for that. Okay, so now we go ahead and put our center drill in there. Okay, we'll go a little bit deeper than that. That's full diameter of the bit, as big as we can go. See what's in there. You can fit in there, it goes. Okay, that's what it looks like in the hole. You know, you can make the chamfer so wide. Okay, so now we need a tap drill for 5/16 18. We're going 1 1/8 deep. And we need a drill which for a 5/16 18 tap drill. That would be an F right there. F drill, 5/16, 18, F. So you can go over here and find our F drill. Scooby has moved all night, see? He's happy. Alright. Oh, he moved his head. He didn't like me stepping on him. What are you doing down there? Yeah. Find ourselves an F drill. This would be an F drill right here. Now, if these are drilled on, if these are straight, yeah, if these are ground on center, they would drill the correct size hole. If they're not drilled on center, go down a couple sides and use this as the final. I kind of like doing that anyway, because you never know where you're at. So we just use this drill right here. So we stick this up in there like that. It's a two-handed operation. Okay, I'm going to point this right now for the drill bit. The old tripod over here. Alright. Okay, that's tight. Okay, you want to go 1 1/8 inch. No, 1 1/8 inch is from the edge of the drill, not from the point. So if you don't know where the edge of the point is, you go like this. Right about there. Okay, then we go up here, we set our depth stop at 1 1/8 inch deep. That's a little bit under 1 inch. Turn it to where you got the ace over here. Makes it easier to see the numbers. What the hell numbers I got on here? Yeah. That was 30 seconds. 4 30 seconds and a little bit less. And that doesn't quite put me where I want to be. We're a little short. So if I kick the pedal over here a few thou, there's an extra 15 on the table. That'll give me what I want. Okay, now we go and drill it 1 1/8 inch in. A little bit. Put light pressure up near your finger. It's not fighting, it goes right in. If you put a little bit of lube on it, cuts a little easier, but you don't have to. As long as you're not fighting it, it's going good. If the drill fights you to go in the hole, which means it doesn't want to drill, and then you better sharpen your drill and put some lubricant on it. Okay, this is the F drill that we're going to use. That was called a pilot hole. Now we'll just run this all the way down until we hit the bottom. The drill's a little shorter, so to go deeper. Yep, it's shorter by that much. Alright, so that's now correctly sized. Now, drill's pretty accurate when you do that. If you do it the other way, you might be off. You might over drill a little bit. It rarely under drills. Over drilling is not a good thing. Okay, now you gotta put a little chamfer on top of the hole. If you just use a bigger center drill, it works really accurate. You can also use a countersink or some other tool. That'd be good for tap. About a 50 thou chamfer on the top, but that's at a 30-degree angle, not a 45, so it's not the same as the other cut we did. Okay, now we can go ahead and put the drill in there, but we got to blow that hole out and make sure there's no chips on the end of it. Pull it out. Should be clean. Get a tap. 5/16 18. This is about 1 1/8 deep. So you measure it, so you know how deep to go. Basically 1 1/8 you go full depth. So here's 1 1/8 right here on my thumb. And you see if you bottom out the thread, you got a little bit of a tit sticking here, but remember the drill had a tit too, so when I'm down to my last thread about right there, that's where we should bottom out in the hole. And if I was in a camera high enough, you would see that. So about 1 thread from the bottom would be the full depth of the tap. That's why I use 1 1/8, because that's what most taps go down to. It also gives you a lot more threads to strip out. If you've got twice as many threads to strip out, it stays tighter and it takes more to pull the strip. Another reason going 1 1/8 and not just down there 700 or so. Alright, I'm just going to power it in here a little bit. So I accelerate up, let it coast, and I shove it in the hole and I'm ready. You got to make sure you don't bottom out right here though. About that speed there. Sometimes it unscrews, sometimes it doesn't. I'm going to zero out my machine up here so I know exactly where I'm at. I'm going to move it out and hand tap it. My hand tapping tool. Used to be able to buy ones like these. This one here looks like it's one that was made. I don't know if I made this one or my dad made it, but one of us did, probably. They pretty much last forever. Unless you do something stupid. If it's tapping freely, just go ahead and continue down. When it gets a little bit hard, stop and blow the chips out. That's a good spot right there. About 3 threads from the bottom. There's a bunch of chips in the bottom of the hole, I'm sure. Your fingers here center it and you swing it like that. And you catch it in the bottom of your finger and lift up. You don't drop your tap. See all the chips in the jam in the bottom? Now this is a regular air nozzle. If you blow on the edge of the hole, the air will go down and blow up a little bit, but not always all of it. The deeper the hole, the less you do that. This here, the air comes out the tip, you shove it all the way down into the hole, and it blows from the bottom and blows it up. This will clean everything out the bottom of the hole. See how it comes up at an angle, and you go like that. You see how a little bit more oil and stuff blew out, but no more chips. But that hole's clean right to the bottom. That's how you make sure you get everything out. Okay, now we can go ahead and put a little more oil back on the tap and run it the rest of the way into the hole. Just kind of jiggle around, let it self-center. It doesn't feel right, don't keep doing it. You shouldn't have to cut. If it was cutting like it was starting to, stop back up and let it find the original hole. If you have to start cutting again, you're cutting 2 threads. Not the way to do it. Okay, half a turn, 1, 1/2, 2, 2.5, and 3 turns more, and we're bottomed. We're almost 1 thread from the bottom, so that's probably all the way down the bottom. There it goes. And see, we don't have to make threads. Didn't have to make chips in the bottom of the hole this time. That's why the tap could go all the way down. I'm going to blow this off again. Okay. Now we now have a hole, a thread. So you can see how it's clean all the way to the bottom of the hole, no threads. Goes in there real deep. There's our bolt. Oops. There was a bolt. Now it's down there, lost forever. I need to go hunting for it. I can get Scooby over here now. Yep, Scooby's thinking about coming this way. down his territory. Okay, this time we don't drop it, see. Alright, so that goes in there fairly decently. This is a grade 8 bolt, so it's pretty good quality. Notice as you rotate it, it's not wobbling back and forth like some of the cheap ass Harbor Freight and Home Depot and other places. Hardware stores are even worse. If your bolt wobbles when you put it in, it's not good. Okay, and I see how this pipe is made. You have a little bit of a low spot right here. That's made so when it pushes right over here on this side, you tighten the bolt further down, it'll actually push the back corner down. Now you notice how that goes in there a little tight. Okay, it's got some drag to it. Pops in. That's how you want it. You can see where my threaded hole is at. See, it's just about dead center, but maybe slightly 5 or 10 thou toward the outside. That gives you maximum holding power on the pipe. It gives you maximum room for bolt clearance. I like to run a solid mechanical lock on here and a hex bolt here. That gives you the most holding power on these pipes. That's if you run a bolt. If you run a stud, then you can run a regular nut. Now you notice how far this bolt goes in there? See, I took that whole bolt and buried it. So I got threads all the way down below them fins height. So it takes a lot of effort to strip this bolt out. When you got that many threads in there, it stays tighter and it doesn't strip out as much. Because we have everything this bolt's got to offer, we took. So you can go in there really deep. Now when you put a stud in here, you can do the same thing. You put a stud in and go way in there deep and bottom the stud out in hard against the inside of the head so it locks it in, and then you can run your nut on top, you're fine. Do not put Loctite on your nut on top. Now a stud and a set screw are different. These are set screws. This is not a stud. Now these should all be grade 8, but they're not always. Most studs should be grade 8, but they're not always either. So you can put these in here, but when you do, make sure you this hex head up here, that your driver that puts it in, make sure that that is not where you're going to be torquing the nut down. Because if you torque on top of this, it'll actually pull the top of the bolt off. Now you saw how long that thing was? That wasn't it. It was this one here. So you would think that'd be too long to use, wouldn't you? But see how much of that's actually inside the port? See, we got that much of that is in the port. See, it's completely buried all the way down in there. Now this one here you take off. If you're going to use a set screw, you can't take a 1/2 inch off because then you'd be pulling on it. So you can take a 1/4 inch less than whatever this is, but that's all you could do. These are probably 2 inches long. Yeah, so you can use a 1 3/4 inch set screw as long as you go. Now on a stud, you can use an 1.5 inch or 1.5 inch or 1 3/4 length stud. Now studs have fine thread on one side and coarse on the other, and a blank part in the middle. That's usually how studs are made. There should be some studs floating around here somewhere. Yeah, see, here's a stud right here. See, most time it's coarse, fine, and then center section. And usually the coarse is a lot longer than the other part, like it should be. So you would have enough length you can jam that thing way the hell down inside of there. Then you have your shoulder where the bolt the exhaust pipe would not eat on threads. So the pipe would be under a smooth condition, which would be good. And then you would have your nut and your lock on top to hold it. Obviously this is 3/8, but anyway, you get the idea. That's what you should be using. So anyway, but if you want to use a set screw, you can use these, but just make sure they're really long like this so you don't have a problem. Otherwise you could have a problem. See, you have different length ones here for different applications, but on these ones here, I'll just use these. Dumbass. See, this is fine thread, this is coarse thread. Now, if you want to use a set screw like this, you take this, cut off this much of it, and you could use this. It'll work. Or you can use like an Evo exhaust stud. They're pretty long too. I think they're about 1.5 inches. You use a 4-speed kicker cover studs, those work real good. They're like 1 3/4. So anyway, you can get what you need, but you can see how many threads you got in there. So it's definitely the way to go. Alright, so now I gotta port the inside out in here and clean up the outside out here, and then that'll be pretty well buttoned up, be done. So I'll do that later. You've already seen me grind stuff before, so I'll finish that up. But I got to come back and weld this all up in here, remachine it where it's all broken in here. So that'll be the next thing I got to do. I hate having to go back and re-weld something I just got done welding on, but at least it's not the same area. Now that porosity is right there. It's not very deep. It's deep because it keeps running across. It's just not very big. And it's a little bit bigger down here. A big chunk right there. So not a very good job. But out here where all my welding rod was at, see, it's clean. It's just this is where the parent material was in here, and I didn't burn out enough of it when I did it. Inferior workmanship on the welding part. Oh well. Alright, so that's it for this. So now you can kind of see how these are done, and that's how they're supposed to be, nice and tight, not wobbling, see? When they're like this, the pipe stays tight and straight and true and all that. Alright, that's it. Bye, Scooby. Time to go home. He's ready to go.